Hi, we are from Group 1 and this is our group member. I'm Aiman.
I'm Izai. I'm Rinsun.
I'm Junwei.
I'm Wanshan.
I'm Wei.
And in this video, we'll be talking about the mechanical property examples of product, mechanical properties, and failure analysis of torsion.
Okay, so couplings are example of engineering product that uses torsion. So what is coupling? Coupling are devices used to connect two shafts together at their ends for the purpose of transmitting power. The primary purpose of coupling is to join two pieces of rotating equipment while permitting some degree of misalignment or end movement or both. So if you look at this video, you could see these are couplings, and then you could see action of torsion here. So other examples of couplings, examples of couplings are beam coupling and disc coupling. This is beam coupling and this is disc coupling. So beam coupling consists of single or multiple helical cuts in the coupling body, which typically can accommodate parallel misalignment up to 0.025 inch and angular misalignment up to 7 degrees. While disc coupling consists of single or multiple discs and single or double stages which bolt to the shaft hubs. They are used for primary transmission and rely on the flexibility of the thin metal disc to transmit torque and accommodate angular misalignment.
Okay, now we are going to application of couplings. We have 5 applications of couplings. First is agricultural vehicles. The second is construction equipment. Third one is industrial equipment, and fourth one is marine equipment, and the last one is mining equipment. So for the next one is mechanical properties of couplings. The first one is lightweight with high torque. The second one is higher torsional stiffness and no backlash. The third one is lower thrust load and bending moment. The fourth one is fit and forget. And the fifth one is easy mounting and dismounting. The last one is superior resistance to environmental conditions. Now let's get to see the video.
Welcome to Lovejoy, where today we would like to demonstrate the proper basic procedures for installing the Lovejoy SX spacer style disc coupling. Lovejoy disc style couplings are ideal for connecting electric motors to fans, blowers, compressors, pumps, and other devices. The SX style coupling utilizes a dual disc pack and spacer design that can accommodate axial, angular, and parallel misalignment. The SX coupling is specifically designed for applications where there is a need to transmit torque between two bearing-supported shafts with a known space between the shaft ends. The spacer configuration is ideal where a lighter weight alternative to a floating shaft is desired. For this installation, please make sure you have access to the
So after watching the video, now we're going to explain the mechanical properties. The first one is backlash. Backlash is the rotational position loss due to a direction change. Zero backlash design available ensure positioning accuracy between driving and driven shaft. However, gear coupling is designed with gear teeth which have high backlash to allow for angular misalignment. This provides flexibility, higher torque rating, and maximum surface-to-surface contact to transmit torque. Now I will continue with another mechanical properties, which is higher torsional stiffness. It is important to positioning applications. It can reduce the level of angular and parallel misalignment they can accommodate. The next mechanical properties is lightweight. It is requirement for lighter weight can be met by using a tap whose main body is made of a light material such as alloy aluminum. Easy mounting and dismounting also one of the mechanical properties of couplings. Couplings can be mount and unmount quickly and easily due to their compactness and small number of parts. The use of spacer with the coupling permits easy mounting and dismounting without the necessity of moving heavy machinery. This is helpful in the replacement of seals and bearings in pump and other equipment. Now I will show another video of action of torsion.
Okay, twin spring coupling test number 2. And start.
The machine will start the torsion action now.
And start.
This part is turning. The angle is now bigger and bigger.
Okay, I'm going to say what torque it's at. 350.
And until a point, you can see there's some deformation here.
$3,000.
The deformation can be seen clearly here. So is the action of torsion.
Hi everyone, so now I'm going to talk about the failure analysis of spring coupling. So basically at here I will discuss about 3 types of failure. The first type of failure is the top failure, top overload. Top overload failure appears similar to fatigue wear, but the grid spring element legs are not centered but rather up or down on the given grid spring element leg. So can see here as the picture show here, there is a up and down. So followed by the second type of failure will be discussed is failure caused by misalignment. Abrasive wear can occur in all coupling that accommodate misalignment through sliding whenever lubricant condition become poor or marginal. So now I will show out a video that will say about 5 types of misalignment.
In this video, we'll take a look at 5 of the most common negative effects misalignment can have on your machinery. Number 1. Seal failure. Mechanical seals are very expensive, and when one fails, fluid leaks can adversely affect other machine components. Number 2. Bearing failures. In addition to the replacement cost of bearings, you may also suffer damage to other components, with an even greater loss to downtime. Number 3. Energy loss. Misalignment makes a machine less efficient, resulting in wasted energy and higher power consumption. Number 4. Increased vibration. Misalignment is the #1 cause of excessive vibration. As vibration levels increase, machinery reliability decreases. And number 5, excessive heat. Excessive heat indicates you have machinery problems. Not only does it contribute to the breakdown of lubrication, it can also pose a safety concern. Shaft alignment of rotating equipment is an essential part of machinery maintenance. Visit vibraline.com to learn more.
So like just now the video has been show up 5 types of common misalignment, and then follow up will be say about the third type of failure, that is fatigue failure. Signature fatigue wear, which can generally be viewed as normal grid coupling wear, show up as crack in the grid spring element approximately in the center of grid spring element legs. As shown in the picture here, you can see that there is a fatigue over this region or this region. This will be the type of the fatigue that has happened compared to this one, the original.
Next, we discuss about the factors of failure of spring coupling. Number one is due to human error, and we can see that it is due to improper material selection, improper manufacturing, and lack of periodic maintenance. All this will cause the failure of the spring coupling, like the photos shown at the right hand side. Next is due to incorrect installation. There are many reasons why incorrect installation results in coupling failure. The most frequent being improper tightening of board, use of low quality boards, key mats of soft steels, and etc. etc. And we can see the example at the picture right hand side. This one is due to horizontal coupling being used vertically. This one is overloading, and this one is excessive interference fit. And the last one is due to effect of base and condition. If the equipments are aligned when they are cold and no compensation for thermal growth is considered, the equipments will probably be running severely misaligned at running temperature, like the example shown in here. Thank you.
Next, how to prevent from failure. First, alignment errors. This misalignment may be angular, parallel, axial, or any combination of these, which call it complex misalignment. Use flexible shaft coupling to allow misalignment and varying degrees of flex. Second, torque. Design selection must be taken into account not only steady state torque but also maximum instantaneous torque. In some cases, designers may wish to view in degree of torsional shock, loads, and peaks. Third, initial speed. Inertia is a body resistant to change its angular velocity. Understand the driving system, inertia, and its effect on the coupling. Shock and backlash. Backlash interrupts or uncouples the transfer of power between the motor or other driver and the load. Damping is particularly important in motion control and power transmission applications where undesirable vibration wastes energy and stresses system component. Shock damping helps reduce the effect of impulse loads and maximize shock to the motor and other sensitive equipment.